Welcome back. This is the second video. We were talking about the densities of space and the contraction of the universe. So why is it inside of a galaxy do the parts that are inside of a galaxy are not expanding away from each other? So there's billions of stars inside of a galaxy. There's a supermassive black hole entity that's also in the center of each galaxy. And so everything is contracting towards this black hole. Why is it that that's not happening like that? Okay, so let's check out what's inside of a galaxy. I've modeled the inside of a galaxy because we definitely don't see ourselves floating away from the Earth at infinite speeds. So let's check out my model here. I gotta find it. Okay, it's over here. So let's pretend that each one of these little cubes here, is a galaxy, and I will show you what's inside of that galaxy. It's a bunch of little stars, as I have drawn here. Now, because these things they're not uniform like I have drawn, but because these things are inside of this chunk, because they're such a tight group, and if you come out here and look, and if you zoom out of the universe and look, galaxies actually look tiny. We can see that with our telescopes, of course. They look so tiny sitting there. But they're actually huge. And so all that matter is localized into one area of the black hole. It makes that area of the black hole denser, and it changes the amount of movement that's allowed, changes and messes with time and energy, and changes and messes with the expansion, which all those things are interdependent on each other, so of course it would change all those things. And so now let's imagine that these are stars in solar systems. So now we're going to follow what it looks like each time, the same thing as before. Each time we are going to shrink them down by a factor of 5, 6.3, and the total size, but then we are going to not shrink the individual ones down quite as much. We're going to leave those lagged behind with a type of impedance, and I just have a random impedance set here of 10% less than the actual contraction, so it's lagged behind. So each time we make this set of this galaxy smaller, the internal components are actually just getting very slightly, ever so slightly larger. And so each time we go down, let's go back up and see where we started. See, I have one block of space. I don't know why this is doing this. I have one block of space between each block. I can fit a whole block between each block, okay, with a little bit of wiggle room. Now each time we go down this rabbit hole, you'll notice that these spaces gets tighter and tighter. Now all I'm doing is shrinking the whole thing and lagging this behind a little bit. Everything's staying relative. So while everything is shrinking into oblivion, into nothing, somehow relatively it's getting bigger and it's expanding. But on an absolute scale, in the galaxy it's shrinking to oblivion, falling into our central black hole. But on a local scale, you and I on Earth actually fall toward the planet. And this is what the universe would do if that's how we just let it sit. It would all collapse in on itself and be done with. Well, this is what a galaxy would do, excuse me. But a galaxy is not just contracting, it is also spinning. So a galaxy is spinning, and what happens when you have something that's spinning? It's repelling its internal components. So while these things are contracting and technically on a mathematical scale, while they're individually expanding, they're also spinning away from each other, which can keep things in orbit. So for instance, it keeps our sun in orbit around the Milky Way center. It keeps the moon and the Earth and all the planets in orbit around the sun and the moon, and maybe some satellites in orbit around the Earth, And it also maintains the orbits in a molecular level, which I do not have drawn up. But essentially, on the molecular level, most of the forces that we have named something else have to do with this expansion and contraction in different ways. And I have many different scenarios. Um, and so, while these things are contracting, they are spreading apart because of spin. So you can see that the Milky Way is spinning. It's a giant spiral. Um, and you can see that the solar system is spinning and the moon goes around the planet. If the moon didn't circle the planet, the moon would just fall toward the planet and crash into it. The fact that the moon is trying to circle the planet means that it's constantly, always trying to break away from the planet, and at the same time, it's constantly falling toward the planet. And the arc that it takes, like when you throw a baseball and the baseball arcs through the air, the arc that the moon takes just happens to swing around the entire planet in a nice clean fashion with never touching the planet ever. And that's how orbit works even with satellites. But on a molecular level, the strong force and the weak force and all these forces are just another version of this, which I'm not going to call gravity, but I'm going to call it the expansion and contraction of the universe, which gives rise to a property that we witness and observe and named gravity. But it also is giving rise to all of these other forces as well, because atoms are on a localized system, not unlike we are on a localized system away from the universe. So our galaxy, each and every independent galaxy, is a localized system. Each and every independent solar system also acts as a localized system, but not enough to outpower what the galaxy is throwing at it, unless, of course, our sun was to turn into a black hole itself, which would be much smaller than the black hole in the center of the universe, so it wouldn't cause an effect on the galaxy, which is why we are a localized entity. And the atoms that make us up are also a localized entity, and they react to the expansion and contraction of the universe in a different way. And in fact, as the universe expands slash contracts, it does it so quickly that it overlaps itself and it ties these complex knots. And as these knots get tied, because they're differentials and they're infinitely small, you can tighten the knot to be infinitely small. You can just keep pulling on that string and the knot will just keep sucking into itself because there's actually no width to the line that you're using. So this is all I have for now.